could it be that until this point I haven't actually made a video on confidential transfers with the token extensions? We gotta change that. Hello and welcome to another Solana tutorial. Today we have a look at the confidential transfers of token 2022, also known as token extensions, because that token program has extensions, one of which is the confidential transfer functionality. And I haven't actually talked about that yet. I've made a video once. No, I recorded the video once when it was in very early stages, but then I couldn't get it to work and then I would never finished that video. And since then, I've been reluctant to make that video, but here I am finally talking about confidential transfers with the token program. This is gonna be more of a high-level overview, more on the user's perspective, or well, actually also dev's perspective, like what you gotta do in order to create a token that can do confidential transfers, what that actually means, like what is confidential about it, and just some high-level overview on the features that we have there. We're not gonna go into the cryptography side of things because that gets really complicated really quickly, and also I don't understand it, so just not gonna go there. But this should still be a very interesting video because confidential transfers is a cool feature that you might want to use. So you might want to know how that works, and I might be able to help you with that. So we have a guide for this. There's an entire section in the Solana docs just for confidential token extension. So you don't find that in the token 2022 extensions guide where all of the other extensions are, but this is actually a whole separate chapter here. And I would say we just slowly go through this, because essentially those are the things that we want to do. I want to create myself a token where I can do confidential transfers. And I think I'm going to do it with CLI as well. Of course, we can have a look at how that's done with the Web3.js or even the new Web3.js. But for today, I think I'm fine just playing with CLI, because if we manually do that, then we manually also need to find the CK proofs and all of that stuff, which the CLI conveniently hides for us. So for now, we're just gonna create a token and have a look what happens on chain. Oh, there's a helper script. What's that? Oh, that's even a, okay, but that's still CLI. This is just all the steps that you do in the CLI as well. Okay, cool. Well, maybe just to get that straight right in the beginning, confidential transfers are not anonymous. So what we're hiding with confidential transfers is the transfer amount. You will still be able to see on chain who transfers to where. You could then do things like transferring 0 tokens to a lot of people in order to, you know, kind of hide your traces in a way. But it is still visible that you transferred something. It's not a full privacy solution where you also get anonymity. Just the amount of token is confidential. On chain, we can't see how many tokens you hold or how many tokens you transferred. But we still see that you have a token account and that you might hold tokens, and the times when you transferred something, even if it's 0 tokens. Just so we got that out of the way. I'm gonna say it a few more times because that's an important thing. People should not confuse that with, oh, I can do whatever, it's not visible, right? It's just confidential, not fully private. Okay, that said, let's create a token. We have to create the token with the new token program, of course, because only the new token program supports confidential mints. And the rest looks pretty much the same as your regular create token would, just that we have this enable confidential transfer flag. And then there's a field. Actually, I'm gonna just start with creating myself a key pair. I don't know, let's go with the classic Andy. Andy C for confidential. And then one for the token, confidential token, CFDT. And then Solana config, set my key pair to this one. Oh, and also we go to devnet. And then we can do this, the SBL token, create token with enable confidential transfers. Copy this. And actually first, let's check help. So we have the enable freeze, enable close, enable group, enable member, enable metadata. All of that is token 2022 stuff. Enable permanent delegate, non-transferable. But the interesting for us is enable confidential transfers. And that has an approve policy. Auto means accounts are automatically approved. So anybody can create accounts that hold confidential tokens, like confidential amounts. You can create a token where not everybody is allowed to use the confidential token transfer feature. So each new account needs to first be approved. This is done with the manual. Then the confidential transfer mint authority must approve each account before it can make confidential transfers. So either we have auto or we have manual. I would now just go with auto because it's the easier functionality. We can have a look at the manual later, or you do it by yourself. I think it's pretty self-explanatory. Maybe I want to have a look at that later, but if I forget or if I don't get around to, because the video is going to be 2 hours anyway, at least you know what it is. But the important thing is that we have this flag such that our mint does support confidential transfers. And you need to specify that at the token creation. Once you created your token and you did not enable this extension, you can't add it later. You need to do this at token creation. That's important. So yeah, let's just do it. We do this whole thing. We create a token, and actually, what did I say? Confidential token something. That's the token I want to create. Oh, hey, yeah, true. Can I have some sol first? And then we do this. There we go. So now we created this token. It has the default 9 decimals, and we can look at this transaction. What happens here? I created this mint. It has a bit more than the standard rent for a token mint because it enabled extensions. So therefore the mint account is a bit bigger, right? That's why I pay a little more in rent here. And what happened? I created this account, and then we did an initialize confidential transfer mint. That's a separate instruction before we initialize the mint, similar to how we saw it at the metadata thing, I think. We have seen this before, where we do another instruction where we first, on the completely empty account, set some extension before we actually initialize the mint. I don't know which video we saw that in, but I think it was in the metadata one. Anyway, then we do the classic initialize mint. That's where all, the decimals and stuff is written into the token account. And then there's just a compute budget instruction. And that's it. Confidential transfer instruction, initialize mint. Do we want to have a look at this account now? Yeah, why not? Probably nothing too interesting here. It is initialized. That's the one, it's initialized. Then we have the mint. And then we have the authority. Is it that way? I think it's that way. Or is it the other way around? Oh, no, hold on. Here's the state. This means it's initialized. This just means it's a mint account and not a token account. Sorry, got that confused. And if you don't know those things by heart, it doesn't matter because you can A, look it up, and B, it's not really that relevant. I just like to look at it low level. And yeah, then it's a bunch of zeros for the freeze authority and whatever. And then come extensions. I think there's one extension, and it's extension number 4. And probably extension number 4 is confidential transfer. Actually, let's have a look at this. SPL token. Token program mint authority supply. Oh, yeah, 9 is the decimals. That makes sense. It's the decimals, and that's initialized. And then it's the freeze authority, and then a bunch of more zeros. Where are the extensions? There, where do I find that? In extension type. But where is that? Okay, I need to clone this. Hold on. Yeah, I dig rabbit holes pretty quickly. There we have it. It is in mod add extension. Why did I not find that? That's literally what I was looking at. Okay, all I wanted to check here was that confidential transfers is number 4. So we have 0, 1, 2, 3, 4. Yes, it's a confidential transfer mint. And then there's also confidential transfer account. That's the extension flag for the token account. And this is the extension flag for the mint. So yeah, we had this when we checked out this account. Here we have one extension, and the extension is 04. So it's a confidential transfer mint. And then what does it store? We could also have a look at that. And that's probably then confidential transfer mint. There's an authority, so the authority to modify the confidential transfer mint. That I would assume is the same as my mint authority, so I would assume that those bytes should be the same as those bytes. Yeah, there we go. That looks about right. So that's my Andy. What's in there? Token basics in the state, mint authority, then supply, then decimals. But what are the other bytes then? Oh, hold on. Wait, so that is part of the mint authority then. That's not even saying that it's a token account. I'm getting more and more confused the more I look at it. So maybe that is the C option with the first 4 bytes that it's present. There is a mint authority. The mint authority. But what is this then? And then the supply of 0. That also makes sense. Wait, hold on. How many bytes is a pub key? 32. And this is 4, 8, 16. I just can't count. This is a pub key, of course. Man, basics. Sorry. Oh, I'm peeking again. I'm too loud. Of course, this is the entire pub key. And this is the C option for that pub key, of course. And then the supply, and then the decimals, and then initialized. Okay. Yeah, so this is the same thing as this. An entire pub key. 32 bytes, damn it. Okay, that makes way more sense. Yeah. Here, those entire... Yeah, and that explains what all of that stuff is. Cool. It's just the pub key. So we said we have one extension. We have extension number 4. So it's a confidential transfer mint account. Not sure what those bytes are. But this is then the actual authority. And then what's after that? The auto approve new accounts that we set to true because we said auto. So I'm expecting the next byte to be 1. Yeah. And then comes the authority to decode any transfer amount in confidential transfer. So that's you can set another account as this global auditor kind of, and that guy will then have access to all of the transfers. So that guy can decode all of the transfer amounts, which also means that whenever you do a transfer, you need to additionally encode the amount for this key and therefore also submit another proof that you did that correctly. It adds a lot of overhead, so it's good that we set that pub key to 0. Those 32 bytes are 0. We do not have another key that can decode all of it. But the functionality for that is there. You can have that. And that's an El Gamal pub key. Because the way we do this, we create separate keys for the encoding of the transfer amounts. We could, of course, use our private key, right? We have the Solana private keys that we use for signing the transactions. But it's good practice to use a different key. Side note, that key is actually derived from our private key, so we can get it deterministically. But it's good in terms of security because just because we have that key, if somebody compromised it, doesn't mean that they can sign transactions for us. They could only see the transfer amounts. Yeah, just some details of stuff that I didn't even want to go into, at least not too much, but just so you've heard it. So cool. We see how this extension actually looks on the account. Let's continue with creating our token because we have a mint, right? We created this mint. That was the transaction. That's the account. It's an unknown token. It's a token 2022 mint with us as the mint authority and confidential transfer active and us as the authority for confidential transfers. Cool. Nice. So we see once again the things that we put in 25 minutes ago because it takes me time to do stuff. Okay, next step would be to create an account. So let's create an account. I'm gonna quickly copy the mint pub key. So we do that the way we're used to doing it with CLI SBL token create account. We create the account for ourselves, so we don't need to say who for, and then we just paste in the mint pub key, and that should do the trick. It should create us an ATA as we're used to. You know, nothing special should be happening here. We should know all of this. Just associated token program create. That's it. And now we have a regular token account. A regular token account with which we can send and receive tokens. So that's the token account. We can also look at it. Look at this account. You know, nothing special. That's the mint. That's the authority. Guess what? We have seen that before, right? That's the ND address. And then nothing special. It is initialized. It has two extensions. One is extension number 7 and one is extension 0. And if we look at this again, So one is uninitialized and one is number 7. 1, 2, 3, 4, 5, 6, 7. Immutable owner. Yes, because the associated token program, is that what it's called? This one, associated token program, yeah. This one does the initialize immutable owner. That's why we have the immutable owner extension enabled. We see that here. Number 7 is the immutable owner and another extension is uninitialized. Guess why? Because we didn't initialize this confidential transfer account. You need to explicitly do that. And how do you do that? Well, in the CLI, there's a configure confidential transfer account. Before we do that, let's use our account as normal though. Just to demonstrate, we can use this account, right? We can say SBL token mint, token mint. And I will need to say how many, I don't know, 100. 100 tokens. And now if I check that account again, what will change? Instead of 0, we will have 100 tokens here. How is that 100? Well, it's 100 billion because we have 9 decimals. Just gotta believe me, that's 100 billion in hex. Little endian. So we have tokens in there, but that's visible on the blockchain. I literally queried it. That's the information on the blockchain. We also see it if we go to that account. Wait, where was it? This one. We will see that the token balance is 100 tokens. This is public information. So every token account, also the ones for confidential transfers, will have the classic token amount. And then there will be a separate amount for the shielded balance or the confidential balance. That's a better word. It's the confidential balance. Yes, yes, yes. And we can, transfer between those. But before we can do that, we need to do that thing where we set that up and actually make space in the account such that it can store that information. And we do that with SBL token configure confidential transfer account and just say at which address. Basically this at the address of my token account. Let's go. And that sends me a transaction. It's actually something that I need to do on the blockchain. Ooh, attempt to load a program that does not exist. Well, that's interesting. What program are you trying to load? Maybe, let's check help on this. Token mint address. Oh, address of the token account to configure confidential. Okay. And the default is the owner's associated token account. But then I can leave the default. Maybe it was just missing the mint. Put in my mint, the CFDT. No, same thing. Attempt to load a program that doesn't exist. What the hell is happening here? Argument token mint cannot be used with address. So I either need to specify this or that. But the question is still, why does that program not exist? Do we need something on DevNet that we don't have on DevNet? Or maybe my CLI is not up to date, but I'm on 1.18.15, or we are at 1.18.18. I don't think that's the difference, but I'm willing to update. It's always good to keep your CLI up to date as well. There we go. Oh, we're at 1.18.23 now. Even better. Does that change anything by any chance? Nope. Huh. Welcome to Random Issues with Solana. I would love, can you dump me what you're trying to do here? I don't think that makes the difference, but I could, of course, provide you with the token program. But no, that's not the issue. What program doesn't exist? Okay, maybe the docs give us something. Maybe that helper script gives us something. No, it also just does create account, confidential, and then... What am I missing? I mean, should I just try it on mainnet? Should I try it on local? I don't even know which program you're talking about here. Attempt to load a program that doesn't exist. Should we dig into the CLI? But is it still not on DevNet? I guess we need to do it locally then. Or on testnet. But I ain't got no testnet, so... Let's see if I can build that. Okay, built. Now we run the test validator with that program from target deploy SBL token 2022. Okay, I have a local validator. Then let's Solana config set to local and do the same things as we did before. We create a token. Oh, first we need sol. And here we can just request, whatever. It's so fun on local. Then we create this token. Perfect. Then we create this account. Create account for this token. Okay, so far so good. Same thing. That's how far we got on DevNet as well. We have this account with the two extensions. One is uninitialized and one is the immutable owner. Okay, and now let's see here if here on local I can do the thing with configure confidential transfer account. Yes, here I can. So apparently something is not deployed on DevNet and mainnet yet. Let's look what actually happens, except I can't because I'm on local, damn it, and I'm on Windows and the Explorer doesn't like that. Yeah, that, okay. The manual way then. The good old CLI way. What happens here? Token program is invoked with confidential transfer instruction configure account, and that returns success. So not much that's happening here, but there will be a change to our account. Let's check the account. Oh look, it got bigger, a lot bigger. Last time when we just checked it 2 seconds ago, this was where the account ended, right? That was it. Hold on, interesting. Okay, I might have gotten that wrong. The 7, because the 7 stays here. Maybe it's 4 bytes. It's weird. Then I would have expected this to go up to 3. Whatever. Maybe it means something different that I misremember. What does that 2 mean? I thought it's how many extensions are active. An extension just has the 2 bytes for the discriminate. So what's those zeros? We don't need to understand it in too much detail anyway. But what we see is we have another extension, the 5. And we saw that before because the 4 was the confidential transfer mint. And this is now the confidential transfer account. So we have a confidential transfer account. Yay! What's in that confidential transfer account? What are all those things? I don't know. Bunch of zeros in the middle and then more data. I don't recognize any of those bytes. What does that mean? Maybe we also find the confidential transfer account. So first there is an approved. Probably this means something else, but this probably means that it's approved. But then what is this byte? Is that somehow the length type of the account? Maybe that's the length of the, could that be 27 bytes? No, makes no sense because that's already 32. Wait, 27, it's not 27, that's 39. Also doesn't make sense. Or maybe those 2 bytes are the length. Oh yeah, that would make sense because then this is the length for this extension and the length for this extension is 0. And the length for this extension is 27 and 1. So 256 plus 32 plus 7, which is 295 bytes. That makes more sense. Just roughly 256 is 8 times 32. Let's just do a rough check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, because that's the 1. And then here we should still have 32 plus 7. So 32 plus 7 bytes. 1, 2, 3, 4, 5, 6, 7. Yes, I know what those things mean. Anyway, it's not so important that you actually know that, but I like to understand what's actually written in the accounts. So this is actually the length of the extension. So we have 250, what did I say? Something as the length for how many bytes are to that extension. And then this is the first byte, which is this approved byte. And then comes the public key, which is this. And this is probably derived somehow from my private key. Sweet. And what comes next is the pending balance, which is 0. I don't know how much of it is the pending balance. And then we have more bits of the pending balance. So apparently that's a bigger part. And then the available balance. Okay, then available balance, which is also 0. And then the decryptable available balance. Don't ask me why that is yet another field. If false, the extended account rejects any incoming confidential transfers. So allow confidential credits. I can unallow to receive. Do I have that? Those are probably those 2 ones. So my decryptable available balance seems to be this maybe, or parts of this. And then I do allow confidential credits, and I do allow non-confidential credits as well. And then the pending balance credit counter is yet another, oh wait, that's a U64. Those 8 bytes. Those 8 bytes are the actual pending balance, expected pending balance credit counter. Then those 8 bytes. Wait, no, that doesn't make any sense. Why do I have a 1 in here? Doesn't matter. Don't think we need to decode that one-to-one exactly. But yeah, those are the things that are stored. Not actually sure what a pod U something means. Yeah, it's 8 U8s. Yeah, whatever. So somewhere in that account, we have the pending balance, we have the available balance, we have the decryptable available balance, we have the pending balance credit counter, maximum pending balance credit counter, expected pending balance credit counter, and actual pending balance credit counter. So we would need to understand exactly how all of that works to make sense of that and why we need all of those things. But maybe start with why there is a pending balance and an available balance, because you might think that one of them should be enough, right? I should have one encoded balance, one confidential balance. The thing is, you always need to provide proofs, right? And for the proofs, they need to have the actual values. So let's say you have 100 tokens in your confidential token account and you want to send 10 of them somewhere. Then you need to, create a proof that has exactly that value of the 100 tokens, the 10, and then you send that. But what if you created proof, you sent that transaction, but before it actually hits the validators, somebody else sends you some tokens and you receive some. So your actual balance is different than the 100 tokens. Maybe you now have 101 tokens because somebody sent you a token. Then the proof is not valid anymore. And that is actually also a possible attack vector where somebody just keeps sending you tokens, thus just so the value changes, just so your proofs are invalid, just so you can't transfer out your funds. And that's why we have this split of the available balance. Nobody can touch that except for yourself. Other people will only get to touch the pending balance, and the pending balance will then need to be converted to your available balance for you to actually use it. That's why there's this distinction. That's low level enough that I wanted to explain it to you. And why we need 2 fields for that, or why we need all of those things. Nah, I don't want to get into that because I don't know. But let's actually do something with confidential tokens. Because for now, everything is still pretty much visible for us, right? We still have our balance up here. Wait, no, where? That's my public key. Oh no, we don't have a balance yet because on my local, I didn't mint any. So let's mint some of those, 100. Let's go. And then if I check the account again, then I should have this balance here. So that's the 100 billion non-confidential. So that's in the regular token account, in the regular amounts field of the token account. And down there where we have the pending and active balance, that's still all zeros, except for that one, but I don't know what that one is. Let's continue in this guide. We did manage to do this. We now gotta deposit confidential tokens. That gets them from the non-confidential part of the token account to the confidential part of the token account. Let's try it. We need the mint pub key. That's our mint. The amount and the address. The amount, let's say 100, and the address. Probably I don't need the address and it will just take my ATA. Let's try. Yep. It just calls a confidential transfer instruction deposit. Doesn't tell me much more. But if we look at the ATA again, we now see that the actual balance is 0 again. And down here we have more data. So this one didn't change. But here we have some. And I'm not sure if that was already here. Might have been here already. Oh yeah, wait, that's because that was the pub key. I want to know how many bytes those are. Can I find that? Elgamal ciphertext, which is what? Elgamal ciphertext length, which is a usize for this and this, which is this, which is 32. So this one is 32, which means this one is 32. But then this one This one is also 32. So which means the ciphertext length is 64 bytes each, meaning that all of those things are 64 bytes, and this is 32 bytes. So we have our extension. It's more of a technical analysis than I thought, but I kind of like it. So this is the pub key. Then this 1, 2, 3, 4 is the pending balance low. Then this 1, 2, 3, 4 is the pending balance high. It's also always two parts. We also saw that. Hold on. It's the previous and commitment length and the decrypt handle length. And possibly the decrypt handle is 0. Yeah, don't ask me how that actually works. But yeah, so that's the pending balance high. And then the available balance, that's those 64, 1, 2, 3, 4. That is still 0. So it looks to me as if we still have a available balance 0. And then decryptable balance, this could potentially just be 32 bytes. Let's check. So that is just the ciphertext, which ciphertext length. Okay, check that out. Which is 36 bytes. Okay. So then we said 36, so that's 32, 3, 4, 5, 6. That's the, what did we say? Decryptable available balance. So here we had the decryptable available balance, and then we have the allow confidential credits and allow non-confidential credits, and then the pending balance credit counter is 1, apparently. And then don't ask me why the maximum is set to, well, yeah, for some reason the maximum is set to 2 to the power of 64? 256 times 256. Yeah, that makes sense. Oh, I can just put in hex. Yeah. So the max seems to be 65k for whatever reason. The maximum pending balance credit counter seems to just be that. Whatever. And the expected pending balance counter is 0 still. And then the actual pending balance credit counter is also 0. So apparently whenever I receive something, the counter goes up or something like that. Maybe that's what that part here is. Anyway, we are analyzing this way deeper than I thought. Because for now, what we saw is our actual balance is still 0. But our pending balance changed. So do I now also need to apply balance? I guess so. Whenever an account receives confidential tokens from transfers or deposits, the balance will appear as pending. Yeah. And we can say SBL token apply pending balance. Let's just do that. And remember how the account looks now versus when we do this. We need the token mint or the token account. It doesn't matter. I can probably supply both. Yep. Also works. And now if we check that account, still a lot of zeros. But the counter changed. So the actual counter as well as the expected pending balance and the actual pending balance credit counter both went up. They're not 0 anymore. But it doesn't look like I have actual balance. Still looks quite 0. Oh no. Look, the pending balance is now all zeros again. First the pending balance high, then the pending balance low. No, other way around. But so this 1, 2, 3, 4 and 1, 2, 3, 4. Both of the pending balances went to 0 now, but therefore I have actual balance 1, 2, 3, 4. I have actual balance now. And don't ask me why the second 32 bytes are still 0 again. That's how this whatever works. But yeah, it's something. Anyway, so in here we have the actual encrypted amount, and from this you can now not tell that that's 100 tokens, except you can tell because nobody else transferred something into my account and I deposited 100, so you're still able to derive that, oh yeah, there's still 100 tokens in there. But now I can start sending it around, and then you don't know anymore how many tokens are in there. So let's do that. Let's send those confidential tokens. How do we do that? Well, with transfer, amount and destination, and just -- confidential, and that's it. For that to work though, we need another token account that actually has the confidential transfer enabled. And that I cannot create for somebody else anymore, like I could with an associated token account, right? A normal token account, let's create ourselves a receiver real quick. A receiver, create account for this owner. That will work. That still works because that's a regular token account. But I will not be able to send tokens into that account. Let's try SBL token transfer. I don't know, 1 token into this account, this mint. Oops. I mean, that would be a regular transfer now. That will not work because I have insufficient funds. And if I say confidential, then it tells me invalid account data because this is not an account that can receive confidential tokens. So I gotta make it a confidential token account with the same as we did here. However, I can't do it for someone else. Owner doesn't match. I will need to do this as the receiver. Oh, this stupid SBL token can't specify the key. This is so annoying. And then I can do this. Okay. And now I configure the other key again. And if I do the same thing now with the transfer, hopefully that will work now. Looks good. I mean, I got a signature. And we got a confidential transfer instruction transfer with split proofs. So probably we sent several transactions. Just that I don't really see this. Should have opened the logs. Wait, let's do another one. Let's do the same thing again. Transfer another token. We get the signature 2 and 5. And my log messages. We've got 1. There we have the signature 379, the signature 4VB, the signature EOG, the signature 5X, and the signature 2N5. So, oh, another one. This was split into 5, 6, 7. 7 transactions. Most of them working with a CK proof program. CK proof. So that was 2 close context states. One was the actual confidential transfer, and there was a ZK proof, and that was a system program one, probably just creating accounts for the CK proof. Yeah, there probably another create account with a CK proof, and another create account with a CK proof, which we then later close here, most likely. So we open accounts for CK proofs, write the data in there such that the token program can then actually do that with the split proofs from 2 accounts. So if we have a look at that transaction, we will see that we have a bunch of accounts. That's the ATA, that's the mint, 4 more that I don't know what they are. Oh wait, that's the receiver. And then those 2 or maybe 3 even, those are probably the accounts from the CK proofs, or at least those 2. Not sure about this one. And then me as the signer, of course. Yeah, those are the accounts that we need for the confidential transfer. So yeah, that's how it works. We create CK proofs, put the proof on chain, then do the transfer instruction, and then we close the accounts for the CK again. So it actually took us 6 transactions for 1 simple transfer, which, you know, more overhead. And that stuff might change in the future where we get it to 1 transaction if we change transaction size limits. I think they're working on that. I think that's something that they want to do specifically for that use case, but I'm not sure. For now, they do it with splitting it into several transactions and splitting the proof as well. So yeah, and that's just with a regular transfer. If there was also this authority that can look at all of the transfers, then we would need to have another CK proof, and then we would need even more transactions, right? We saw that earlier in the mint specify this auditor Elgamal pub key. Then we would need another CK proof, so probably another 2 transactions. Cool, but we were able to do a transfer. Let's check the account. I don't think we see much different here. Those values changed. And now it's very difficult to tell how many tokens I still have in there, because I can't decode that, because nothing on chain tells me that I transferred 2 tokens. I could have transferred twice 0. I could have transferred twice 50 tokens and have 0 tokens left. We don't know, because that stuff now is confidential. And that's the entire use case of this. That's why we do this. That's why we create all of those proofs and accounts and make it so complicated that it's not publicly visible anymore how many tokens we transferred. It's still visible that we transferred. It's still visible that we uploaded our proofs and that we did a transfer instruction. And also it's visible where we transferred to. The recipient is known. We are known. The recipient address is known. The only thing that's hidden is the amount. That's important. And the recipient account, I think that was the DZH. The recipient account probably has something in the pending balance now. And see, this is fun. There we don't have the zeros anymore. Probably because it received and I encoded it for them or something. I don't know. I don't know how it actually works. But we see that the pending balance, high and low, has values. Let's check the counter. The counter is actually 2. The maximum is 1 and the actual counters are 0. So if we receive it, then we will set the counter to 2 probably. So first, to get from the pending balance to the actual balance, we will need to do that thing again where we apply pending balance. Let's do that. Let's apply for this account. Let's go. Okay, check that account again. What changed? Well, here the pending balance now is all 0 and the available balance has values. Also here, we don't have the zeros anymore. That's cool, interesting. And as I said, the counter went to 2 and this one back to 1. Interesting. Do I need to now do that several times for everyone that... No, that doesn't make sense. I don't think it would change if I do it again, but let's try if I do that again. Now this is still 1 and those are not 2 anymore, but 0. And did those values change? No, those values did not change actually. But interesting, the actual from 2 went down to 0 again, and this is still 1. Weird. So it probably didn't do much except for reset that counter for whatever reason. Yeah, don't ask me how that works. But the point is we have some actual balance now. And to get out that balance, we gotta withdraw. So if we have available confidential balance and we wanna get it out into the non-confidential balance, you know, that part up here that is currently 0, we should be able to withdraw SBL token, withdraw confidential tokens for this mint. And we want to withdraw 2 tokens. Boom. Withdrawing 2 confidential tokens went through. And if we check that account, what has changed? The confidential balance has changed, of course. Wait, that's the confidential balance. That's the confidential balance. That value has changed. It's still not 0, so it's still not clear that there are no more tokens in there, even though we know that there are no more tokens in there, but nobody else can tell because they don't know how much we transferred. And we see that up here in the actual balance, those are 2 tokens now. So this should be 2 billion. And again, you just gotta believe me that that's actually 2 billion because I ain't gonna... Although, wait, 773594000. 2 billion. There you go. Trust me. And this is unconfidential now. This is publicly visible again. And now I can transfer them like normal tokens because they're back to being normal tokens. I don't need ZK proofs anymore to transfer that. This can now be used as the regular token from the Token 2022 program. And that's how I work with confidential transfers. That's pretty much it. There's always this confidential part in the token account and the non-confidential part in the same token account. And we could now have a deep dive into how that actually works with encryptions and whatever, but not today. There is nice documentation on it if you're interested. Also, before they had that documentation, there is the ZK token protocol paper in 2 parts that also read pretty well, especially the first part, because the first part is written for, you know, regular people. The second part is where it gets super technical then. with the proofs and everything, and very mathematical actually. If you're interested, you can read through that. You can go through the docs here. For me, it is enough that I showed you how it works and what happens on chain. We also saw that it's not live on DevNet yet, apparently. We're still missing a program. Probably the CK, this one, the CK proof one. Maybe, I don't know. No, we already failed at the creation of the token account. I don't know. Something is missing or something is not right there. It will probably come to mainnet eventually. I don't actually know the times for that. But yeah, I think I'm good with that. I think I want to end it here. We did see some things. At least we got a base understanding of how confidential transfers work, what you got to do to those accounts. And just as an overview, this should be enough to get you started using confidential transfers if you want that for your token. There's so many more things that we could have a look at. You know, the manual approval for the accounts, the auditor's pub key, and the actual encryption and stuff. It's a big topic, and I want to take it in small chunks. And just as an introduction, I think it's good for today. Make sure you are subscribed so you don't miss videos if I make more about the confidential transfer extension. Let me know in the comments if you want more videos, if you want to go even deeper, or if that's good enough for you. There's some more videos that you can watch. If you enjoyed this content, give it a like, share it with your friends, and I will see you in the next video. Till then, bye bye. And send your tokens confidentially.